You might think ancient people were just sitting around waiting for someone to invent the wheel or discover iron. But high in the Andes Mountains, the Inca were busy proving that sometimes the best solutions don't come from having the latest technology. They were moving stones that weighed more than modern trucks, building cities on mountaintops that would make today's engineers scratch their heads, and creating structures so precisely fitted that you can't slide a knife blade between the blocks, all without a single iron tool or wheeled cart in sight. Let me tell you something that will blow your mind. The stones at Sacsayhuaman, one of their most famous fortresses, include blocks weighing over 200 tons. That's heavier than a fully loaded Boeing 747 airplane. Now imagine trying to move that thing up a mountain using nothing but human power, ropes, and some very clever thinking. The Inca didn't just figure out how to do this once or twice for special occasions. They built an entire empire this way, stretching over 2,500 miles along the western coast of South America. The real kicker is that these weren't desperate people making do with limited resources. The Inca had access to bronze tools and knew about wheels from their neighbors, but they chose different methods. Why? Because what they developed actually worked better for their specific challenges. Try rolling a wheel up a 60-degree mountain slope sometime and see how far you get. The Inca looked at their environment and said, "Forget wheels, we'll build something that actually makes sense up here." Their empire lasted less than 200 years, but in that short time they moved more stone than the Egyptians used to build the pyramids. The difference is that the Egyptians had relatively flat desert and the Nile River to help with transport. The Inca were working in some of the most challenging terrain on Earth, where the air is so thin that modern visitors get altitude sickness just from walking around. Yet somehow, they managed to create architectural marvels that have survived earthquakes that destroyed later Spanish colonial buildings built right next to them. Here's where things get really interesting. The Inca didn't just randomly start moving massive stones around. They had a systematic approach that turned their entire society into a mountain-moving machine. Every technique they developed, from their rope making to their organizational systems, was designed around the reality of working in vertical landscapes where traditional methods simply wouldn't work. The foundation of their stone-moving success started with something most people never think about when they imagine ancient construction: ramps. Not just any ramps, but a sophisticated system of earthen ramps that could handle loads that would crush modern equipment. The Inca were basically the masters of turning steep mountainsides into manageable slopes, but their ramp technology went way beyond just piling up dirt. These weren't simple straight ramps either. The Inca built zigzag ramps that wrapped around hillsides like giant staircases. This design served multiple purposes that showed just how clever their engineers were. First, a zigzag ramp is much gentler than a straight ramp trying to cover the same vertical distance. Instead of hauling a massive stone straight up at a brutal angle, workers could move it back and forth in manageable segments. Think of it like switchbacks on a hiking trail, except designed to handle blocks of stone that weigh as much as a house. The construction of these ramps was an engineering feat in itself. They didn't just dump loose dirt and hope for the best. The Inca built their ramps with carefully graded surfaces, drainage systems to prevent erosion, and retaining walls to keep everything stable. Some of these ramps were over half a mile long and rose hundreds of feet in elevation. Building the ramp sometimes took as much effort as moving the stones themselves, but it was an investment that paid off when they could move massive blocks efficiently and safely. What made their ramp system truly brilliant was how they integrated it with their workforce organization. The Inca had perfected a labor system called mita, which required communities to contribute work time to state projects. This wasn't random labor, though. Different communities specialized in different aspects of construction. Some groups became experts at ramp building, others at rope making, and still others at the actual stone-moving process. The numbers behind their ramp operations are staggering. Archaeological evidence suggests that some of the larger construction projects involved ramps that required moving over 100,000 cubic meters of earth just to create the transport routes. That's enough dirt to fill about 40 Olympic swimming pools. and all of it had to be moved using nothing but human labor and simple tools. The precision required was incredible too. These ramps had to be built to exact specifications, because a slope that was too steep would make moving stones impossible, while one that was too gentle would require ramps so long they'd stretch for miles. But here's what really sets Inca ramp engineering apart from other ancient civilizations. They designed their ramps to be temporary. Once a construction project was finished, they would carefully dismantle the ramps and use the materials for other projects. This shows a level of planning and resource management that would impress modern project managers. They weren't just building ramps, they were creating reusable infrastructure that could be adapted for different sites and challenges. The most impressive example of their ramp technology was probably at Ollantaytambo, where they transported massive granite blocks from quarries located across a valley and up the opposite mountainside. The ramps they built for this project had to account for crossing a river, navigating around existing structures, and climbing over 1,000 feet in elevation. The logistics alone would challenge modern construction companies with all their machinery and computer planning tools. Of course, building perfect ramps was pointless if you didn't have the right tools to actually move the stones. This is where the Inca rope technology becomes absolutely crucial. While other civilizations were developing metal chains and pulleys, the Inca were perfecting rope systems that could handle loads that would snap modern cables. Their ropes weren't made from just any plant fiber either. They used a specific type of grass called ichu that grows in the high Andes, processing it through techniques that created incredibly strong and flexible cordage. The rope-making process itself was a specialized skill that took years to master. Workers would twist individual fibers into strands, then combine multiple strands into progressively thicker ropes. The largest ropes used in construction could be over 6 inches thick and hundreds of feet long. These weren't just oversized versions of regular rope, though Inca rope makers understood the physics of load distribution and created ropes with varying thickness along their length to handle stress more effectively. Testing has shown that Inca rope construction techniques produced cordage that was actually stronger than some modern synthetic ropes. The secret was in their twisting method, which distributed stress evenly throughout the rope structure. They also developed techniques for splicing ropes together to create even longer lengths without weak points at the joints. Some of the rope systems used in major construction projects involved continuous ropes over 1,000 feet long, all hand-twisted from mountain grass. The Inca didn't just make strong ropes. They created complete rope systems with different types of cordage for different purposes. Thick hauling ropes for moving stones, thinner guide ropes for controlling direction, and specialized shock-absorbing ropes that could handle the sudden stress changes that occurred when moving massive weights over uneven terrain. They even developed rope padding systems to protect the stones from damage during transport and prevent the ropes from cutting into the rock under extreme loads. What makes their rope technology even more impressive is how they maintained and replaced it. Rope systems used in major construction projects had to be constantly inspected and maintained. The Inca developed standardized testing methods for checking rope strength and established replacement schedules to prevent failures that could result in crushed workers and damaged stones. They essentially created the world's first industrial rope management system, centuries before anyone else even thought about such concepts. But having perfect ropes was useless without knowing how to use them effectively. And this is where the Inca developed techniques that would make modern crane operators jealous. They created pulley systems using nothing but wooden rollers and carefully positioned anchor points carved right into the living rock. These weren't simple straight pull operations either. The Inca figured out how to redirect forces around corners, up steep inclines, and even across gaps where direct pulling was impossible. Their pulley systems worked on principles that wouldn't be formally described by European engineers for another 200 years. They understood mechanical advantage instinctively, creating rope and pulley combinations that could multiply the pulling force of their work teams. A group of 50 workers could generate the pulling power equivalent to several hundred people through clever use of multiple pulley points. The physics were the same as modern cranes, just executed with organic materials and human engineering genius. The anchor points they carved into cliff faces and boulders were works of art in themselves. These weren't just random holes drilled into rock. Each anchor point was carefully positioned based on the forces it would need to handle, with specific shapes designed to distribute stress and prevent the rope from slipping under load. Some of these anchor points are still visible today, carved so precisely into granite that they look like they were made with modern power tools. What really sets their rope and pulley systems apart is how they coordinated the human element. Moving a 100-ton stone isn't just about having strong enough ropes. It's about getting dozens of people to pull in perfect synchronization. The Inca developed elaborate signaling systems using drums, horns, and visual cues to coordinate their work teams. Imagine conducting an orchestra, except instead of violins and flutes, you're coordinating teams of rope pullers spread across a mountainside. The most challenging aspect wasn't the initial pulling. It was controlling the stones during movement. A massive block sliding down a ramp can build up tremendous momentum, and stopping it requires techniques that go way beyond just pulling harder on the rope. The Inca developed braking systems using friction, controlled rope slippage, and even deliberate obstacles that could slow down runaway stones without damaging them. They also had to account for the unpredictable nature of moving massive weights over uneven terrain. A stone that moved smoothly for hours could suddenly hit an unexpected bump or soft spot and require immediate adjustments. The Inca work teams had to be ready to instantly redirect forces, add additional pulling power, or implement emergency braking procedures. It was like driving a 200-ton vehicle with no steering wheel, brakes, or engine, using only human coordination and rope technology. The scale of their rope operations becomes clear when you consider that major construction projects involved rope systems stretching for miles. At Machu Picchu, stones were transported from quarries located over 20 miles away, requiring rope systems that had to be maintained and coordinated across an entire mountain range. The logistics of just keeping track of all the ropes, pulleys, and anchor points would challenge modern project managers with computerized tracking systems. But moving stones was only half the challenge. Once you got a massive block to its destination, you still had to place it precisely in position. This is where the Inca developed lifting techniques that seem almost impossible given their available tools. They created temporary structures that could raise stones vertically and position them with millimeter precision, all using nothing but wood, rope, and human ingenuity. Their lifting systems relied on something called cribbing, which involved building wooden frameworks underneath and around stones to gradually raise them to the desired height. Think of it like building a wooden tower around the stone, then using that tower as a platform for lifting operations. The process was slow and methodical, but it could handle weights that would crush most modern wooden structures. The precision they achieved with these lifting systems is almost unbelievable. At sites like Sacsayhuaman, stones weighing over 100 tons are positioned so accurately that the joints between them are virtually invisible. Modern architects struggle to achieve this level of precision with laser-guided equipment and computer-controlled machinery. The Inca did it with wooden levers, rope systems, and careful observation of how stones settled into position. They also developed techniques for fine-tuning stone placement after the initial positioning. Using wooden wedges, rope adjustments, and carefully applied leverage, they could shift massive blocks by tiny increments until the fit was perfect. This fine-tuning process sometimes took days for a single stone, with teams of workers making minute adjustments until every surface aligned exactly as planned. The lifting operations required an understanding of balance points and weight distribution that would impress modern engineers. The Inca could identify the exact center of gravity for irregularly shaped stones and design their lifting systems accordingly. They developed techniques for handling stones that were not only massive, but also awkwardly shaped, with protruding sections and irregular surfaces that made conventional lifting impossible. What makes their lifting achievements even more remarkable is that they did all this work at altitudes, where the thin air made physical labor incredibly demanding. Modern construction workers require oxygen supplements to work effectively at the elevations where the Inca built some of their most impressive structures. Yet somehow, these ancient engineers maintained the precision and coordination necessary for delicate stone placement while working in conditions that would exhaust trained athletes. The wooden frameworks they built for lifting operations were engineering marvels in themselves. These temporary structures had to support weights that would crush normal buildings, while also providing the flexibility needed for precise positioning adjustments. They used interlocking wooden joints that distributed loads evenly and could be disassembled and reused for different projects. Some of these lifting frameworks were over 50 feet tall and required as much engineering skill as the permanent structures they helped build. The coordination required for these lifting operations was like conducting a three-dimensional chess game where every wrong move could crush someone. The Inca developed a whole system of specialized roles within their construction teams. You had the rope masters who understood exactly how much tension each line could handle, the balance specialists who could read how a stone would shift as it was lifted, and the positioning experts who could judge distances and angles with an accuracy that would make modern surveyors jealous. But here's where things get really wild. The Inca didn't just lift these massive stones straight up and plop them down. They developed techniques for rotating stones during the lifting process, allowing them to orient blocks to exact specifications while they were suspended in mid-air. Imagine trying to flip a 50-ton stone upside down while it's hanging from ropes 20 feet off the ground. One wrong calculation, and you're not just dealing with a dropped stone. You're looking at a catastrophic failure that could destroy months of work and potentially kill dozens of workers. The rotation techniques they developed used controlled rope slippage and carefully timed adjustments to multiple lifting points. By gradually shifting the balance of forces around a stone, they could make it rotate slowly and predictably. The math involved in calculating these rotations would challenge modern engineers with computer modeling software. The Inca did it all by eye, experience, and an intuitive understanding of physics that came from years of hands-on experimentation. Their lifting operations also had to account for wind conditions at high altitudes. A massive stone suspended on ropes becomes a giant sail when mountain winds start gusting. The Inca developed stabilization techniques using guy ropes and counterweights to keep stones steady during lifting. They even had weather specialists who could predict when conditions would be suitable for delicate lifting operations. The most impressive aspect of their lifting technology was how they handled stones with irregular shapes. A perfectly rectangular block is challenging enough, but the Inca often worked with stones that had complex curves and angles. They developed custom lifting harnesses for each individual stone, using rope configurations that matched the unique balance points and stress patterns of every block. It was like creating a custom-fitted suit for each stone, except the suit had to be strong enough to support 100 tons of granite. Once they mastered the art of moving and lifting individual stones, the Inca faced their ultimate challenge, fitting these massive blocks together with precision that still baffles modern observers. This wasn't just about stacking stones on top of each other. Inca stonework features complex interlocking joints where each block fits into its neighbors like pieces of a three-dimensional puzzle. Some joints have up to 12 different contact surfaces, all cut to tolerances measured in fractions of inches. The fitting process started while the stones were still at the quarry. Inca stoneworkers would rough cut blocks to approximate shapes, but the final fitting happened at the construction site through a process of gradual refinement. They would position a stone against its neighbors, mark the high spots where it didn't fit properly, then remove the stone and carefully grind away material until the fit improved. This process might be repeated dozens of times for a single stone. The tools they used for this precision work were surprisingly simple, but incredibly effective. Bronze chisels, Stone hammers and abrasive sand were their primary equipment. But the real secret was in their technique. Inca stoneworkers understood how different types of stone responded to different cutting methods. They knew exactly how hard to strike a chisel to remove just the right amount of material without causing cracks or unwanted fractures. The abrasive techniques they developed were particularly ingenious. They would mix sand with water to create cutting paste, then rub stones against each other using the paste as an abrasive medium. This method could achieve incredibly smooth surfaces and precise angles, but it required enormous amounts of time and patience. Some of the more complex joint surfaces show evidence of hundreds of hours of careful abrasive work. What makes their fitting techniques even more remarkable is that they achieved this precision while working with stones that weighed tons. You can't just flip a 20-ton block over to work on the bottom surface like you would with a small carving project. The Inca developed methods for working on stones in place, using mirrors made of polished metal to see into tight spaces and curved tools that could reach areas that were otherwise inaccessible. The quality control standards they maintained would impress modern manufacturing operations. Every joint had to meet strict tolerances, and stones that didn't fit properly were rejected and reworked, regardless of how much time had already been invested. Archaeological evidence shows that some sites have piles of rejected stones that were almost but not quite good enough to meet Inca standards. But the most mind-boggling aspect of their stonework wasn't just the precision of individual joints. It was how they managed to create walls where every stone fit perfectly with all of its neighbors simultaneously. This required planning and visualization skills that seem almost supernatural. Each stone had to be shaped to accommodate not just the stones directly touching it, but also the overall structural requirements of the entire wall section. The Inca developed systematic approaches to this complex fitting challenge. They would lay out entire wall sections on the ground first, working out all the fits and relationships before any stones were actually installed in their final positions. This process, called dry fitting, allowed them to solve the three-dimensional puzzle aspects of their stonework before committing to permanent installation. Their dry fitting areas were like massive stone workshops spread across level ground near construction sites. Workers could roll stones around, test different combinations, and perfect their fits without having to deal with the complications of working at height or on steep slopes. Some of these dry fitting areas covered several acres and contained hundreds of stones in various stages of preparation. The mathematical complexity of their fitting systems becomes clear when you consider that changing one stone often required adjusting several of its neighbors. The Inca developed techniques for managing these cascading changes, working systematically through wall sections to ensure that modifications in one area didn't create problems elsewhere. It was like solving a Rubik's Cube where each piece weighed several tons. Once the dry fitting was complete, the real challenge began: transferring the perfectly fitted stones to their final positions without losing the precise relationships they had worked so hard to achieve. This required marking systems that could track the exact orientation and position of each stone, plus transportation methods that wouldn't disturb the carefully achieved fits. The marking systems they used were works of art in themselves. Each stone received unique symbols that indicated its position, orientation, and relationship to its neighbors. These weren't just simple scratches either. The Inca developed sophisticated coding systems that could convey complex three-dimensional information using combinations of geometric symbols. Some stones have markings so detailed that they include information about which side should face up, how the stone should be rotated, and even which end should point towards specific compass directions. The transportation of fitted stones required special handling techniques to prevent damage to the carefully shaped surfaces. The Inca developed protective wrapping methods using padded materials and special rope harnesses that avoided contact with critical joint surfaces. They also created handling procedures that ensured stones were never placed in positions that could cause stress damage to their precisely cut edges. But even with perfect planning and execution, the final installation process was where everything came together or fell apart. Installing pre-fitted stones in their final positions required lifting techniques that could position massive blocks with millimeter accuracy while maintaining their exact orientational relationships. The Inca developed installation procedures that were like choreographed dances, with teams of workers executing precisely timed movements to guide stones into their final positions. The installation process often revealed small discrepancies that had been missed during dry fitting. The Inca were prepared for this, maintaining teams of specialist stone adjusters who could make final modifications while stones were in their installed positions. These craftsmen could remove tiny amounts of material from specific areas using specialized tools and techniques that wouldn't disturb the overall structural integrity of the wall. The precision adjustments they made during final installation were like performing surgery on a stone patient that weighed more than a school bus. These specialist craftsmen had to work in incredibly tight spaces, often lying on their backs underneath massive blocks, using tools that were essentially oversized dental instruments. One wrong tap with a chisel could create a crack that would compromise the entire joint, turning months of careful work into expensive rubble. What made these final adjustments even more challenging was that they had to be done while the stones were under load from their neighbors. The weight of surrounding blocks created stress patterns that could cause unexpected fractures if the adjustment work wasn't done with perfect technique. The Inca stone adjusters developed an almost supernatural sensitivity to how stones would respond under these conditions, learning to read the subtle signs that indicated when a stone was ready to crack versus when it could handle more material removal. The tools they used for these delicate operations were marvels of specialized engineering. Tiny bronze chisels no bigger than your thumb, curved scrapers that could reach into corners that seemed impossible to access, and abrasive stones shaped to match specific joint geometries. Some of these tools were so specialized that they could only be used on one particular type of joint configuration. Master stone adjusters carried toolkits that contained dozens of different implements, each designed for a specific type of precision work. The quality standards for these final adjustments were absolutely fanatical. Joints had to be so tight that water couldn't penetrate them, yet the fit couldn't be so tight that thermal expansion would cause cracking. The Inca understood that stone expands and contracts with temperature changes, and they built these minute movements into their joint designs. This required calculating tolerances that accounted for seasonal temperature variations, altitude effects, and even the different expansion rates of different types of stone. But here's where things get really mind-bending. The Inca didn't just fit stones together randomly. They organized their entire stonework according to sophisticated structural principles that distributed earthquake forces throughout their buildings. Living in one of the most seismically active regions on Earth, they had to design structures that could flex and move without falling apart. Their interlocking stone joints weren't just about precision fitting. They were about creating flexible connections that could absorb tremendous forces without failing. The earthquake engineering built into Inca stonework was centuries ahead of its time. They understood that rigid structures break under seismic stress, so they designed their walls to move as unified systems. Each stone was positioned not just to fit perfectly with its neighbors, but to contribute to the overall flexibility of the structure. When earthquakes struck, Inca walls would sway like trees in the wind, with each stone shifting slightly, but remaining locked in place by the complex geometry of its joints. The mathematical principles behind their earthquake-resistant design required understanding force distribution patterns that weren't formally described by European engineers until the 20th century. The Inca figured this out through observation, experimentation, and generations of accumulated knowledge about how different joint configurations performed during actual earthquakes. They essentially developed empirical engineering principles through trial and error, testing their designs against some of the most powerful natural forces on the planet. Their seismic design philosophy extended beyond just individual walls to entire building complexes. The Inca planned their structures so that different sections could move independently during earthquakes while remaining structurally connected. This required coordination between multiple construction teams working on different parts of the same building, ensuring that joint patterns and stone orientations created the desired flexibility characteristics throughout the entire structure. The most impressive example of their earthquake engineering is probably Sacsayhuaman, where walls containing stones weighing over 200 tons have survived centuries of seismic activity that destroyed later colonial buildings. The secret wasn't just in the individual stone joints, but in how the entire wall system was designed to distribute and absorb earthquake forces. The zigzag pattern of the walls isn't just decorative, it's a sophisticated engineering solution that creates multiple force distribution paths during seismic events. But all of this precision stonework was pointless if they couldn't get the materials to the construction sites in the first place. The Inca developed transportation networks that could move massive stones across some of the most challenging terrain on Earth. Their road systems weren't designed for wheeled vehicles. They were engineered specifically for human carriers and the unique challenges of moving heavy loads through mountain terrain. The road building techniques they developed were almost as impressive as their stone moving methods. Inca roads weren't just paths cleared through the wilderness. They were engineered transportation systems with carefully graded surfaces, drainage systems, and supporting infrastructure designed to handle the specific requirements of stone transport. Some sections of Inca roads were built to tolerances that would meet modern highway engineering standards. Their road grades were calculated to optimize human carrying capacity over long distances. Too steep, and carriers would exhaust themselves quickly. Too gentle, and the roads would stretch for impractical distances. The Inca found the sweet spot that maximized efficiency while minimizing fatigue, creating road systems that could move enormous amounts of material using nothing but human power. The engineering challenges they solved in road construction were staggering. Mountain roads had to be carved out of cliff faces, with retaining walls and drainage systems that prevented erosion and rock slides. Valley roads had to include bridge systems that could handle both regular traffic and the special requirements of heavy stone transport. Some Inca bridges were engineering marvels that could support loads equivalent to modern truck traffic. The most famous of their transportation innovations were the rope bridges that spanned deep mountain gorges. These weren't simple rope swings. They were sophisticated suspension bridge systems that could handle heavy loads and provide stable platforms for stone transport. The engineering principles behind these bridges were essentially the same as modern suspension bridges, just executed with organic materials and human engineering expertise. Their rope bridge technology required understanding cable dynamics, load distribution, and structural stability principles that wouldn't be formally described in engineering textbooks for centuries. The Inca developed these principles through hands-on experimentation and accumulated practical knowledge, creating bridge designs that performed reliably under conditions that would challenge modern engineering teams. The maintenance requirements for their transportation infrastructure were enormous. Roads had to be constantly repaired and upgraded to handle the wear and tear from heavy stone transport bridges, required regular rope replacement and structural inspections to prevent catastrophic failures. The Inca maintained specialized teams of road and bridge engineers whose only job was keeping their transportation networks operational. But the most remarkable aspect of their transportation system wasn't the roads or bridges themselves. It was the organizational structure that coordinated material movement across their entire empire. The Inca developed logistics systems that could track and coordinate the movement of thousands of tons of stone across hundreds of miles of mountain terrain. This required communication networks, scheduling systems, and resource management capabilities that would impress modern supply chain managers. Their communication system used relay runners who could carry messages across the empire faster than horse-mounted messengers in flatter terrain. These runners, called chasquis, maintained communication links that coordinated construction projects, material deliveries, and workforce assignments across the entire Inca road network. The logistics coordination they achieved, using nothing but human messengers, was more sophisticated than many modern construction projects. So there you have it. The Inca took one look at impossible mountain terrain and said, "Challenge accepted." They moved stones that would make modern cranes sweat, built cities that laugh at earthquakes, and created transportation networks that put our highway systems to shame all without a single piece of iron or a wheel in sight. The next time someone tells you that ancient people were primitive, remind them about the civilization that turned physics into art and mountains into masterpieces. Sometimes the most impressive technology isn't the newest, it's the one that actually works.